In this video, we're going to discuss similar triangles. The nice thing about similar triangles is the ratio of their sides are congruent. What that means is if we have two similar triangles, they don't have to be the same size. So for instance, in these two triangles, side A does not equal side D. They are not the same size. But if I take the ratio of two sides in our smaller triangle, say A to B, that will be equal to the ratio of the corresponding sides in the bigger triangle. Let's talk about what we mean by corresponding sides. Notice where A is. The side A corresponds to the side D in the bigger triangle. Sometimes you'll see this notation. A corresponds to D. So that means, and side B corresponds to E. So A over B is going to be equal to D over E. And that's a nice property of similar triangles. There's another way we could set up our proportion. Now I did it, small triangle equals big triangle. But it turns out we could actually do, let's say we wanted to do side C, which corresponds to side F. Then I could look at the ratio of C over F. Alright? That'll be equal to a ratio of other corresponding sides. Either two. I could do A over D or B over E. So let's do B over E. Now, here's what's important when you're setting these up. Notice that A over B is part of the same triangle. They're both part of the little triangle and they're on the same side. D and E are part of the big triangle and they're on the same side. Setting them up this way, notice that C and B are part of the little triangle and F and E are part of the big triangle. So they have to be matched up horizontally. So you either have to match them up vertically or horizontally as part of the same triangle. I would not have wanted to do this. I would not have wanted to say C over F equals E over B. These are not part of the same triangle. That is not a true statement. So that's how we set up similar triangles. Now how this works, let's give these some sizes. Let's say that A equals 2 and that B equals 3 and D equals 6, and they want to know what E is equal to. This is how we would set up this problem. Well, I would take the ratio of my sides, A over B, so 2 over 3 equals, and I set it up A over B, so I have to set it up D over E, is equal to 6 over, now instead of using question mark, how about we use a variable, say x. And we now have a proportion that we can solve. To solve this proportion, I like to do cross multiplying, which is multiply the denominator by the other side. That leaves me with 2x equals 6 times 3, which is 18. I can divide both sides by 2, and I get that that missing side, E, is 9. Now, let's just take a look and set it up the other way and make sure we get the same thing. So I know that side A is 2 and its corresponding side is D is 6. So I could set that up. Here I'm going to put D on top, so 6 over 2. So this is D over E. Let's make a note of that. D over E equals, and now E is what I'm looking for, and B I also know. E and B are corresponding sides. Notice, sorry, I have a little error here, that should be A. Notice that D and E are part of the same triangle. They have to go on either the same horizontal or same vertical. I did vertical, so E, my question mark, which we're using X for, has to go on top. Now the side E corresponds to the side B, which is 3. Okay. Now, we don't need to use cross multiplying every time. I'm going to show you a little bit different way of solving this. Because I have 6 over 2, I can treat that as 6 divided by 2, and I get 3 equals x over 3. Now I need to get rid of this 3 in order to solve, so one way of doing that is multiplying both sides by 3. Those cancel, and yet once again I get x equals 9, or that side e is 9. And we looked at a couple different ways of setting up our proportion and a couple different ways of solving our proportion.